For our project, our group chose to look at the law of conservation of momentum. Some examples of this physics concept in everyday life include football players colliding, a bowling ball striking bowling pins, or pool table balls hitting one another. Momentum is defined as mass in motion and is a measure used to determine how much mass is moving, as well as how fast it's moving. The mathematical expression for momentum is P equals mv, P being momentum, m being mass, and v being velocity. The law of conservation of momentum states that within a closed system, the momentum will be equal before and after a collision. This means that if a certain amount of momentum is lost by one object in a closed system, it will have to be gained by the other object. This idea is mathematically expressed by the equation P1F minus P1I equals negative P2F minus P2I prime. We wanted to find the velocity of two objects before and after a collision so that we could use the information to determine its momentum. After running into a few problems while trying the experiment on other objects like basketballs and marbles, we decided to use air hockey pucks. Because the pucks are floating on air, it makes friction less of a problem. Before making them collide, we obtained the weights of the two pucks. We then recorded the trials using the Vernier Video Physics app from an aerial view in order to get the velocity of both pucks. For the velocity versus time graph for puck 1, the velocity before the collision was 2.665 meters per second. For puck 2, before the collision, the velocity was negative 3.362 meters per second. Using the equation P1F minus P1I equals P2F minus P2I prime, we gathered that the initial momentum of the pucks was 37.01 grams per meters per second squared. Because the momentum should be equivalent before and after the collision, this number is our theoretical value. For the velocity versus time graph for puck 1, after the collision, the velocity was negative 3.027 grams per meters per second squared. For puck 2, after the collision, the velocity was 2.667 grams per meters per second squared. Once again, using the equation, we found that the final momentum of the pucks was 34.95 grams per meters per second squared. To calculate the percent error, we compared the change of momentum of object 1 to the change of momentum of object 2, because according to the law of conservation of momentum, these values should be equal. We calculated our percent error to be 5.57%. The slight percent error could be due to the difficulty of selecting points on the video for the after track. Another reason could be the fact that the table was tilted in respect to the camera, which is also a bit shaky. Thanks for watching.